Hi, so today we are going to talk about our second video, and this time, in the last video or in the last class, we learned how to find limits using graphs, kind of see how to guess a limit by using a graph. But we can do it all the time because sometimes drawing the graph is not easy for a function. We need to find some other ways of finding limits. Now we know from math 110 college algebra that a function can be represented in many ways. So one way would be a graph. Okay, the same function can be represented as an equation. Now let us see whether there are any rules that will help us to calculate limits when the function is given as an equation. So so here are some rules, right? So these rules are very useful. The first rule is that if the function is a polynomial. So what's a polynomial? A polynomial does not have x in the denominator as such, right? It's just a string of powers of x. You can see a nice polynomial here. For example, x squared is a polynomial because it only has x squared and there's nothing in the denominator. And what about this one right here? X cubed plus 3x squared plus x plus 2. That's also like a string of powers of x joined together and no denominator. So that's what a polynomial is. On the other hand, if I may go to the next slide, now this is not a polynomial. Why? Because this has x on the numerator as well as x in the denominator. So this is not a polynomial. This is a rational function. But let's get back to polynomials. The simplest rule that I can teach you is this. Now, if you have a polynomial and if you want to find the limit at a certain point, all you need to do is to plug in the number for x and you will get the answer. This is only true for polynomial. Now you may say, hey, you are cheating. You told me that it is not important what the value at the point is. That is true. Now just take a look at this graph x squared. Can you see the graph? Now the limit means you want to check the behavior as x approaches to. But this graph is very smooth and there are no holes in the graph. So therefore really the behavior as x approaches to from left or from right is the same really as what happens at 2. In a way we say that this graph is continuous. It's nice and continuous. So really the limit is equal to the value at 2. Now that is true for any polynomial because all polynomials are smooth and continuous. So remember, when you have a polynomial, if you want to find the limit, just take the value and plug in. So if it is x squared, you want to find the limit as x goes to 2, just plug in x equals 2 and then you get 2 squared, which is equal to 4. So the limit is actually 4. Now let's go down to another example. Suppose you want to find the limit of this polynomial x cubed plus 3x squared plus x plus 2. Once again, it's a polynomial, so we are not worried. Just plug in the value of x, right? So the limit value, which is 1, so 1 cube plus 3 times 1 squared plus 1 plus 2. So 1 plus 3, 1 squared is 1, 1 plus 3 is 3, so 1 plus 3 plus 1 plus 2. So 4 plus 5 plus 2 is 7. So the answer is 7. 1 cube plus 3 plus 1 plus 2. So 1 plus 3 plus 1 plus 2, 1 plus 3 plus 1 plus 2 is 7. Alright, so the limit actually is equal to 7. Now what if you don't have a polynomial? Now when you don't have a polynomial, when you have a quotient, be very, very careful. What it says, if you look at this theorem, it says that if the limit of the denominator is not 0, then you can still plug in. Okay, now you got to be careful. Okay, so when you see a quotient, the first thing that you should do is go to the denominator. So now the denominator here is x plus 2, right? Okay, plug in or find the limit of that. So that the denominator itself is a little polynomial, so you can just plug in the value of x. See what happens. You get what? 2 plus 2. Okay, so now if you have 2 plus 2, right, is it 0? Is it 0? No, 2 plus 2 is not 0, it's 4. So no problem. So if it's a no problem, this is fine, fantastic, right? Just plug in the value. So you plug in 2 squared minus 4 divided by 2 plus 2. So you get 4 minus 4 divided by 2 plus 2 is 4. So 4 minus 4 is 0. 0 divided by 4, we are okay because 4 is in the denominator. 0 divided by 4 is 0. So the limit of this function is just 0. Now let me give you another example where life is not so easy. Okay, take this example, x squared minus 4, but this time I have x minus 2. So guys, remember, when you have a quotient, the very first thing you do is you go to the denominator and just see what you can get by plug in the value of x to x. Go to the denominator, plug in for x. So if you plug in x equals 2, what do you have? You get 2 minus 2, which is 0. This is a problem. The moment this is 0, you cannot use this theorem because it says not 0. Can you see that, right? Okay, alright. So then if it is 0, we have problem. So cannot substitute, cannot plug in. So when you have a quotient where the denominator is 0, when you plug in the number, do not plug in. Stop it right there. Most of the problems that you will get will be of this type, so be very, very careful, very careful. Now let's see how we can actually handle a situation like that. When you have a situation where the denominator goes to 0, like last time, the way out would be to factor the numerator and the denominator. So now when we have x squared minus 4 over x minus 2, okay, can you see that numerator is a difference of two squares, right? X squared minus 4 is 2 squared, correct? Okay, so I can factor this as what? X plus 2, x minus 2, and then the bottom is x minus 2. Now can you see that the x minus 2 and x minus 2 cancels out? Very good. And then you are left with just x plus 2. But so you want to find the limit as x goes to 2 of x plus 2. But x plus 2 is a polynomial, so we don't have a problem there. So if you want to find the limit, what you do is we just plug in x equals 2, right? Because it's a polynomial, you can just plug in. So when you plug in x equals 2, what do you get? 2 plus 2, which is 4. So 2 for x, 2 plus 2 is 4. So remember, when you have a situation like this, when the denominator, okay, goes to 0, so when you plug in 2, you can see very clearly that you get 2 minus 2, which is to 0. So it is a problem, right? Okay, so it's a problem. Okay, so we put a unhappy face there, right? Okay, no problem. Okay, so what you do is you factor the top and the bottom, and then we can put a happy face there. Okay, and then we got rid of that painful x minus 2. We got a polynomial. Factor the top and the bottom and cancel out the common factor. It will always cancel out. I'll make sure that you get problems where things cancel out. Okay, so now what happens is that so you can put, now you got a polynomial put, and then you're okay. All right, very good. That's, and then we will see you in class.